All right, today we're going to look at graphs of functions. We want you to be able to identify domain and range and also use transformations. Let's start with domain and range. In your own words, kind of think of what those mean. So pause the video, kind of think through that and see what you got. All right, hopefully you came up with at least some of these words here. Domain, that's your x values. Whereas range, that's going to be your y values. Some other ways you can think of this too, x values, we know that's going to be left to right here on your graph, whereas y values would be up and down on your graph. Some other ways to think about these is domain is, since it's your x values, that's your input, whereas the range, that's your output. One other last one that some people have said in the past is that kind of like input and output, this is your independent variable, where you can put in anything you want, but y values are dependent then on what you put in for that independent variable. So those are just some terms that you may have thought of when talking about domain and range. Let's see if we can come up with domain and range on a couple graphs here. So for A, we have this parabola graph, and let's assume this keeps going on both sides. What would the domain and range be here? So domain, that's our x value. So we want to look at kind of left and right here. Are we covering all our x values? Yeah, it certainly looks like it here. Like if we travel up or down here to the x-axis, we're hitting every x value along the way. And it will keep going here forever and ever. So on this one, it looks like it's all real numbers, or with our interval notation, that would be negative infinity to infinity. Our range, that's our y values. Now we're looking up and down here. Do we cover all of our stuff that way? Well, for sure down, this is going to keep traveling forever on both sides down. So it's going to, for sure, go all the way down to negative infinity there. Does it keep going up forever? No, we do have kind of a cap or top on this one. It looks like we never get above 4. So the biggest output value we can get is 4, and include it because we do have a point there at 4. So that would be the range. Let's look at B. B, let's also assume keeps going here. Will we, left to right here, will we have all our values for our domain here? Well, it's not moving very fast, but this is going to go over here as we go up. So we should hit all the values along here. Same with this one. This one is going down. So eventually we should hit all the values there as well. So I think on this one, it also looks like what we had for the A one is that our domain is all real numbers. Our range, our output, this one for sure, it's going to keep going up and down, and we got all the values in between. It's continuous. This would also be all real numbers here for our range. All right, let's look at one a little bit different here. This is kind of more of a choppy piecewise graph. Just to be a little bit different here, let's not assume these go forever. Let's say this one stops here, and just to be a little bit different, let's say it's open right there. Okay, so what is domain and range here? So let's start with our domain. That's our x values. So we want to look left to right here. Do we have all our x values? Well, we don't have, since it stops here, we don't have anything outside of -5. So it starts there. We're traveling left along here. Looks like we got all the values there. Okay, we stop at -1, but then we do hop up here, and it looks like we got all the other values, and we keep going. So it looks like everything's covered between -5 and where we end, and where we end would be at 2.5 for our x value. So this would be 2.5, except I did put an open circle there, so we wouldn't be including that. So it'd be parentheses instead of bracket, because we don't have a point there. Let's check our range now. That's our y values. Um, our y values on the bottom there, we definitely are going across here at -1. You can see we got points all along there. So we do have a point at -1 to -1. I guess it's just kind of staying there. So it's just that singular point. And then we jump up, and so we're going to union. We got some more y value points up here. We stay at +1, and then we move up here, and we end at 2.5, not counting that. So we do have all the values in between as well. So this would be from 1 including it all the way up to 2.5, but we don't have a point there, so we would not include 2.5. So that would be the range for that graph. So just identifying what's the x values and y values, the inputs, the outputs. All right, the other thing we're going to look at is some of these transformations. When you do transformations, the graph you kind of begin with, or the most basic graph, is called your parent function. So the ones we're going to look today have kind of these three as its main parent function, but you could have other ones. One of them we're going to look at is quadratic graph or a parabola. So if you have just f of x equals x squared or y equals x squared, that's this U-shaped graph that starts at the origin. And then because we're squaring, like if you put 1 in, 1 squared is 1, so you get the point 1, 1. If you put 2 in, 2 squared is 4, so it's up 4. Same with the negatives. -1 squared is also +1. -2 squared is also +4 because -2 times -2 is 4. So it's going to kind of have that basic U shape to it. Another graph here, square root graph. Almost like kind of half of that parabola over there, but sideways, because here if you put 0 in, 0 squared is 0, 1 squared is 1, 4 squared, square root of 4 is 2, so there'd be a point there, and so on. So it's just square rooting all the numbers. Kind of, again, it's this shape, but the shape we had here, but sideways, kind of opening to the right. Absolute value graph, you've seen that before as well. That's kind of that V-shaped graph. Absolute value symbol there. That's the positive value of everything. So 0, 0, 1 would be 1. Absolute value of 2 is 2, 3 is 3, and so on. Absolute value is always positive, though. It's distance from 0, so absolute value of -1 is also +1. -2 is +2, and continuing off that way. So that's absolute value graph. Transformations, that's changing it. The three main ones we're going to look at today. Translations, that's sliding it or shifting it left, right, up, or down. Reflections, that's going to be a flip over either the x or y axis. And then dilations, that's changing it, either making it narrower or wider in shape. So same shape, but narrower or wider. Translations, let's look at those first. We've done a little bit with these so far. If you're adding or subtracting outside your function, that's going to shift it up or down, and it's just what you'd normally think. Plus is up, and y is down here for these. If it's inside your function, adding or subtracting, then it's opposite what you'd normally think. So subtracting something actually moves it right. Adding something actually moves it left. So insides, left and right, and opposite. Let's look at one, see if you can get this here. So the parent function is in blue here. That's our one we saw before, f of x equals x squared. So you can see all these graphs have that parent function in blue here somewhere. Which one is the translation in red that would match this function g? So I'm going to give you a second, see which one you think. All right, hopefully you've had a chance to look at all of them. Let's see what you picked here. This is outside the function, so that should be moving it down 1 because it's minus. This -2 inside, that's going to move it left or right, but remember inside's opposite. So this is going to go right 2, and so the one that shifted it right 2 and down 1 was B. If you had picked B, you have the correct one. We went right 2, down 1. That's the new vertex point of that parabola. Reflections, if there is a negative inside or outside, that's going to flip it. Negative outside, outside's always vertical, so this is going to flip it up and down over the x-axis. A negative inside, inside's always horizontal, this is going to flip it horizontally left and right over the y-axis. Examples here. If you got your square root function right here, if there's a negative outside of that, which you can see here, that's going to flip it vertically over the x-axis. Now our graph's in green there, the one that looks like this, same shape, but flipped over the x-axis. Here's an example of one where it's inside the function. So we got our square root function again. If the negative's now inside, that's inside's horizontally, so it's going to flip it over this y-axis here and be off to the left there in red. Dilations, that's going to make it narrower or wider. So if you are multiplying a whole number to your function, that's going to stretch it vertically by whatever that number is, because you're multiplying each of the y values by that number. If the number is between 0 and 1, meaning it's like a fraction such as 1/5, that's really like dividing by 5. So that's going to compress it vertically by that number. Some examples. Here's our square root graph. The blue one is our kind of our parent one here. If you were to multiply 2 to the outside of that function, that's going to stretch each point up by 2. So for example, if this was at, let's say that point was at 1, 1. Now if you multiply by 2, now it's up here at 2. You've stretched it by a factor of 2. Whereas if it was multiplied by 1/2, that's kind of like dividing by 2. So if this was 1, 1 again, dividing that would put this now at half here instead, because we've shrunken that y value up. All right, so let's look at some examples here. On this one, graph these two. So this one here is our parent function. That's our absolute value of x. We've seen that before. It's going to have its vertex at 0, 0, 1, 1, 2, 2, 3, 3, and so on are all points. This side's just y equals x. On the other side, we got negative 1, 1, negative 2, 2. So on the graph on this side is y equals negative x. Slope's negative 1. So there's our parent function. Now let's see if we can do this transformation. So we got to figure out what are the things here doing. Let's start with that. What's that going to do? That's inside the function, so that's going to shift it left or right. And it's always opposite inside, so this one's going to move left 1. So it's going to move our graph from being at 0, 0 to now right here. We also have a negative. So now instead of the negative outside is going to flip it vertically, so up and down over the x-axis. So now instead of opening up, this should open downwards instead. It's gonna be going down this way. Okay. And then finally we got that 2 there. So what that 2 is going to do is it's outside the function. It's going to multiply each value by 2. So if we went over 1, instead of going down 1, we're now going down 2 instead. Same thing the other way. If we go over 1, we should go down 2 instead of just 1 point. And that would kind of continue here on both sides. So that graph is going to be a little bit narrower than the one above. So the graph of that one should look something like that. How you can get that if you are unsure where those points could go, you could make a little table. So for example, if we had x, and I'll put our parent one on here first, f of x, like if we had the points, okay, these would be, these are ones from our parent function, the one in blue. I'm going to call this one g of x just so it's something different here. This one then, since it's doing that negative, it's going to flip it to the other side and then times by 2. So our new one here, you would try to be finding those points by multiplying each y value by -2. So now instead of each of those, you times it by a -2. So like this one would turn into -4. This one would turn into -2, 0, -2, -4. And then to get our new x ones, we'd want to, we get that shift over here of +1. So since it's left one, we'd have to -1 from all these. So our new x values would be like if we -1 from this, -3, -2, -1, 0, and -1 from this would be 1. And so these points should all be on here, like 1, -4, that's the point right there. 0, -2, that's our point there. -1, 0, that's our point there. So you can see that those points end up in the same spot. All right, let's again graph our parent one first here. This is the x squared graph. So that's that parabola starting at the origin. 1 squared is 1, 2 squared is 4, 3 squared would be 9. Got symmetrical points here on the other side. So there's our parent graph. Now let's graph this one. Let's see what our transformations are doing. That's outside, so that's up 3. This is horizontal, but it's opposite because it's on the inside, so that's going to be right 2. And also we got a reflection here. It's a vertical reflection. And so that would be if it's flipping vertical over x-axis. So let's see if we can come up with those new points. So let's shift the vertex first. We want to go right 2 and up 3. So that's going to be new vertex right there. And then it's going to get flipped vertically over that line. So that would mean all these points are going to open down now. So if I went before to get these first 2 points here, I went over 1, up 1, we'd go over 1, down 1 instead here for those. The next one, if you square 2 or over 2, you go 4 because 2 squared is 4. So if I went over 2, I'd go down 4. There should be a point there and a symmetrical point over here. If we want to get one more, you could square 3. So if I went over 3, I should go down 9 now. So there'd be a point there and a symmetrical point over there. So this one should be opening down because it got reflected over the x-axis. So that would be the graph of this one. Let's try one more. Square root of x is our parent function there. 0 squared is 0, 1 squared is 1, 4 squared is 2. We could get one more. 9 square root of 9 is 3. And so there's our parent function. It's going to keep going there. Remember, there's no points over here because you can't square root a negative. All right, let's see our new one. This is moving it down 4. And then we got half here, so that's going to divide each of our y values by 2 there. It's going to be half as much. So first off, let's move our down 4. So now it's here. Before, to get this point, we went over 1 to the right and up 1. So if we went over 1 again, instead of going up 1, this is being compressed by half, so we'd only go up a half. The next one we had was over 4, we went over 4 and up 2 to get to that point. So if we went over 4 again, instead of going up 2, we'd only go up half of that, so we'd only go up to 1. Our other number here, if we went over 9, before we went up 3, we only want to go up half of that, so we'd only go up 1.5 here. So this graph is going to look more like that when we graph that one out. So that would be the points located there. So that's kind of graphing using transformations. That's what you're going to be working on your assignment.